It was, I think, the win of the America's Cup 2003 by the Alinghi team who really pushed me in the composite field. I was 10 years old at that time, but I remember clearly looking at the regatta with my grandpa. That was a big impact for me, setting up this course on composites. You can have the best material in the composite world, but if processing is a nightmare, even if it's a cheap product, it ends up being very costly. What I really like as well is to be able to bring to the clients good products that they are able to use on their production lines, and everybody's working in CompPair. They all dream to see the more and more parts in the market with our materials inside.
So today we are at CompPair. We had a great tour with Amaël through the facility, and now we are moving into an interview with Robin, the co-founder and CTO. So let's jump right into the interview. Hi Robin.
Hi.
Nice to see you again.
Nice to see you too.
And thanks for having us today here in your facility.
You're welcome.
Maybe from a historical point of view, when did you start the company and when did you move into this facility?
Oh, it was quite a rock and roll start, let's say. The company, we worked on it as a project since 2019. Then we founded the company itself in January 2020. Mm-hmm. And we moved here in 2020, but it was not in this building, it was in the other building.
Okay.
And yeah, we had 3 moving before entering this area and having this facility with the lab and workshop downstairs, the offices and everything set up.
Cool. So before we move back to the company and the people inside the company and what you are doing on the technical side, maybe a few words of introduction, who you are, where you are coming from, what is your background?
I'm coming from the region. I'm originally from Morges, just next to Lausanne. I did my studies at EPFL in material science. I started material science because of composites. So it was a field I was very interested in since the beginning of my studies. I went then in McGill University in Montreal in Quebec for my master's thesis. It was on sandwich structures for space applications. And then I moved back here and started the project with Amaël and Véronique, our third co-founder and professor at EPFL.
Okay. So you mentioned you were attracted by composites. Why is that? Why composites?
I'm an avid sailor, and basically on a boat you have composites everywhere, from very cheap composite to very high-end composites. And it was, I think, the win of the America's Cup in 2003 by the Alinghi team who really pushed me in the composite field. I was 10 years old at that time, but I remember clearly looking at the regatta with my grandpa on the TV at 3 in the morning. That was a big impact for me, setting up this course on composites.
Okay, so quite interesting. So from Switzerland to sailing, winning the America's Cup, and then studying composites, starting your own company. You mentioned Véronique Michaud from EPFL, pretty famous in the ecosystem here. And how does it come that you met Amaël during the classes? Why do you kind of build a friendship and then decide this crazy idea to start a company?
I met Amaël through my studies. I'm a bit younger than him, so he was a PhD student at the time. Yeah. And he was one of the fun PhD students coming to the parties. And students liked him because he was was setting some very high goals in terms of projects for his PhD. So students working with Amaël, they knew it's tough, but you learn a lot, and he's a really good guy. So that's how I knew Amaël. I followed his PhD defense from Montreal. And then coming back into Switzerland, basically we met at the bar at EPFL, presented me the first PowerPoint on the CompPair idea. And from then we got along really good, and we decided to go forward, and like step by step we built also our relationship and the company in parallel, and he's now a close friend, and it's really a pleasure. We have different mindsets. He's very optimistic, and I'm a bit less optimistic. So it's a very good combination, because then we always end up on some common agreements or shared point of view. But yeah, it's really pushing our thinking forward. Sometimes a bit too negative, sometimes a bit too optimistic, and we always found a common ground, and it's really great to have somebody like him.
So you would say this challenging each other is essential in growing a company, not to be too biased and eventually too optimistic, or too, I would say, or less optimistic and eventually not taking a step further.
Yeah, exactly. Because we are very well aligned on our values, on ethics, and so on. So it's already a really good foundation. And then the way we see opportunities and threats, it's a bit different. And then we exchange a lot on that, and a lot also on how to grow the company in a sustainable way, because it's great to be a young company, but what's greater than that is to be an old company.
Yes.
And that's what we really aim at CompPair.
Okay. So before coming back to the values, because this is essential for, as you say, anchor a company in the ecosystem, let's go back to maybe Switzerland, the education system. I mean, we are super lucky in Switzerland. We have ETH and EPFL, well-known to universities worldwide, actually, on engineering topics.
Yeah.
And now you mentioned there's this Professor Véronique Michaud in the game somehow. So how does the system and eventually some individuals in the system support this going from an idea, a PhD, to spinning off, creating a company? Is there a process? Are there support functions? Maybe tell us through your experience.
My experience, it's really people-based in the end. You have a great ecosystem, a great system with some flaws, like any system anyway, but it's really people-based. And Véronique, she's a great person. She had numerous projects on self-healing composites. They made a choice at the beginning of Amaël's thesis to use a bit of heat to activate the system.
Yeah.
And from there it was a really great success story. And I have many different links with Véronique. My sister went to school with one of her sons, and yeah, it's really funny. And now she's into the company, but as a scientific advisor.
Yeah.
And we really like to exchange with her, because we are pushing boundaries on what's feasible with Healable composites. So it's exploring new grounds, and having somebody with such an experience and such a knowledge, it's very valuable. And she's a very nice person, and it's always a pleasure to exchange with her. And she's also very interested by, she's a scientist. She really likes to learn, and I think she really likes also to see how a PhD project from her lab is becoming really an anchored company in the composite field.
Yeah.
and the business side and understanding how it works and the difficulties that's behind it. Also something that is interesting for her.
I think she likes that there is an impact of the education, the ideas, and then anchoring that and having an impact in the industry.
Yeah,
that was certainly true. Yeah. And now let's come back, because obviously, okay, you start the company, you are two people with your differences, and then you said values, you're aligned on values.
Yeah.
And now how to anchor that when you grow the company, because you bring in many different people, a lot of diversity of profiles, sales, technical people, etc. How do you make sure that this group, like a composite, is bonding well?
It's values again. The value we cherish with Amaël, we have them in the company. It's the values of the company, and that's the value we believe in. And people joining CompPair, they also believe in these values, and that's the common ground to have a lot of diversity across the profiles and country of origins and everything. And mindset, but if you have common values, then you can really bring together this expertise, those sensitivities together and work really in a productive way.
Yeah. And now let's move from the people to the technology, obviously. I mean, you are formulating resins, so you're really at the early stage, I would say, of the entire value chain of composites, but you are pretty broad. So you formulate resin, but then at the end you supply to the market some intermediary products, so including the fibers. Maybe you can walk us through what are the in-house capabilities and how you are then in relationship with the broader composite market.
So in-house capabilities, it starts from the formulation, because we do all our formulation inside, so we keep the core knowledge internally into the company, and we keep also the resin manufacturing inside the company as well. And what we do is to then subcontract the pre-impregnation of the fibers to SHG Composite, which is not only a technical partner, but also a commercial partner.
Okay.
And that's how we operate. And thing is, we have this healing capability, and it's a new feature, and also that's something that needs to be quantified. And unlike the traditional features or characteristics you have, such as toughness, strength, and so on, healing is not a characteristic which is well defined in standards, ASTM or ISO standards. So there is a lot of work to be done also with the people who are implementing our product on the lines, and also the people designing final products, to understand really well the value of the healing, both from the economical and ecological standpoint. Meaning that depending on the actor we're speaking with, they will create value internally using our composite, or by selling them to an end user who will benefit from the repair. And it's really dependent on each case. But yeah, the core knowledge is really, we have understood how to create those healable systems. And the core competence we have is to broaden the product portfolio. Because in the composite industry, every actor has different needs based on the product they want to make. And if you look at the big players, they have really a broad product portfolio answering the needs of market. So that's what we're doing. We have 3 prepreg families, 2 liquid system families, who are developing, as an example, bio-based healable prepregs, fire retardant prepregs with the healing, and exploring a lot of different options also to play on the processing parameters.
Okay, and now you are mentioning, I mean, that's a key issue sometimes in composites. On one side, we are expecting very high performance. On the other side, to make the business happen, often we need standardization. So we are always in between tailored products and trying to standardize. And on the application fields, I understood from Amaël previously, you are focusing currently on one side on sports, on the other side on, I would say, aerospace and mobility in general.
Yes.
And those markets, if you look at the technicality and the certification loops, are very different. So how do you approach, as a material or formulator, this long way to certification, if I take some aerospace applications?
It's really based on market pool. We have a strong market pool, then we assess, okay, should we develop a product for this specific market? For example, cabin interior for aviation. The answer was yes, so we went into that direction, and then from there we look at all the certification we need to have, all the criteria that the material must pass to be able to be certified and used in the application. And basically that's how we are working. It's based on market pool, and from there we see, okay, what are the certification, and then from there we say, okay, let's build a development roadmap, implementation roadmap, and that's the way we think it's the right way to do it, to operate from a market pool, and then say, okay, we go or we don't, depending also on the economical benefits that are behind.
Yeah. So if you take the customer journey, the customer has a specific need, specification eventually, or functionalities, then how does the formulation start, and maybe how long does it take from first formulation, some iterations, then you go up to the product, you make some prototypes, they are tested. So how long can such a cycle be?
From 4 months to 3 years. It really depends on what we are looking for.
Yeah.
Some parameters are more difficult to change, to optimize. So yes, it really depends on what we are looking at as a system. And what we are doing is, okay, across the different sectors, from space, aeronautics, sports, you have also common needs.
Yes.
And we tend to group, okay, we have those actors, they have these specific needs, so we'll develop a product answering those needs. We're a small company, so we try to refocus as much as we can the resources. And that's why we are not delivering tailor-based resin systems to everybody, but it's more based on applications or regulations or this type of things. Okay, we have one resin system, it can be applied here, here, and here. And if we pass this certification, then we can apply it somewhere else.
Okay, so it means, if I take an example, if I'm in the low temperature field, it might support skis in sports and some applications in space.
Yeah, exactly. Or in boat building, or in mobility, as an example. It depends, because in composite industry you have various temperatures. You are occurring from room temperature up to 180 or 200 degrees, and the tooling, equipment, and processes that are behind are very different. and you need to adapt the material to be able to answer, okay, this material can be in that range of temperature, so it can be cured between 140 and 180. This one, it's more 120, 150. This one, we can cure it from 60 to 80 degrees. And that's one of the key parameters in the industry is the process. Is it infusion-based or liquid resin, or prepregs? And then the temperature and cure time, it's really critical.
So it's beyond the knowledge of the use case, which is going outside at the end. It's a lot of knowledge in the processing, obviously.
Yeah, processing is the key, because you can have the best material in the composite world, but if processing is a nightmare, even if it's a cheap product, it ends up being very costly, because then you need to adapt strongly your process, and it's very difficult. So there is this point, and the other one is really to be able to provide products to people without to have them to change their process. Because whether it's a small or a big company, it's always the same. If you're changing manufacturing processes, you are up for unexpected mistakes. So the less we change, the better it is, and it's a case for everyone. Small company of 5 people, they are doing things in a certain way, they are used to that, and they make good product because they really understand well their process and they are familiar with their process. Bigger companies, it's the same.
Yeah. So basically, when you are testing new formulations, you often go to the customer's production site and you really get deep into their process parameters, their routines, and you try to adapt really your recipe to their settings.
Exactly. The implementation phase of a new material on a production line, it's a crucial point, because you need to be able to make it work properly, end up with very high quality parts in the end. And for one product, you can process it out of autoclave, in a press, in autoclave, and so on. So you need to tailor not necessarily the formulation, but maybe just the resin content you have in the prepreg, because it will not be the same for the press, the out of autoclave, or the autoclave processing.
Oh, super interesting. And now maybe let's move forward. I mean, we saw the pyramid of circularity, and obviously you are tackling the upper stages with just longevity and prolongating the lifetime, obviously, through repairability. But at one day it will be end of life anyhow. So how easy is it to recycle these special formulated resins?
We are working with recycling companies in the composite field, and what we have done is to give them some of our old parts for them to run some tests and recycle them, and it's thermoset based, so it's recyclable through the current channels that we have. We have some demonstration from a few years ago where we were able to make a part and then recycle the fabrics and make the part again with the same reinforcement.
Okay.
So it's quite interesting. So that's one approach, and I think it's a crucial point is to be able to propose to our clients, saying, hey guys, we know that it's longer lasting, but it's not everlasting. So we are working with this and this company for the recycling of the composite at the end of life. I think it's a crucial point. And the other crucial point regarding recycling is to be able to use recycled materials and bring them back into the market. And I think that's one of the biggest challenge in the composite world today is, okay, I have a recycled materials, I cannot reach the original properties, and it's not necessarily cheaper. How can we use that, and what can we make from that feedstock, from that recycled feedstock? And there is a positive momentum. People are willing to use recycled fibers, recycled materials, and so on. But the way we use it in the composite field, it needs to be really well thought, because you cannot use it for any application. But they have very interesting properties as well. Combined with healable resins, you can end up with great products. But it's a challenge. It's also a challenge to change the mentalities within the composite world, because we're using the same reinforcements, same resins from 20, 30, 40 years ago, and the industry is used to those products, and bringing change, understanding that some new materials, they are not performing as well in strength and stiffness, for example, but they have other advantages in terms of processing, or even in damping properties, or some interesting ratio to make some evolution in designs as well. So it's always difficult to make innovation happen. A lot of companies are talking about innovation, not that many of them are actually pushing innovation.
Yeah, I think the critical point, as you mentioned, is really implementing innovation so that it has a sustainable impact into the industry. And maybe a last few words on what is looking forward, I mean, for CompPair, for yourself, what is the most exciting challenge on the technology itself and maybe on the company journey?
Personally, is the healing. I think that attracts me the most, because to be able to repair and heal a composite, you need to understand how they are damaged, and that's very critical point. And I think it's also the case for different fields, but it's very difficult to replicate damage or an event that happens in the real life of a part within a lab. Because you are always taking some hypotheses, and the composites, they are highly anisotropic materials, and the damage mechanisms, they are very complex. And it's very interesting to understand how they get damaged, and then how we can repair them really efficiently. So that's my personal thing, let's say. And what I really like as well is to be able to bring to the clients good products that they are able to use on their production lines, and have parts in the real world, in the market, in use with our materials. And that's really what push the company, I think. And everybody working in CompPair, they all dream to see the more and more parts on the market with our materials inside.
I mean, thank you, Robin, so much. I mean, I'm also looking forward to use some of your materials, maybe hidden in some skis or bicycles. Let's see. The best luck to you, to your company, and see you soon in Switzerland or outside.
Yeah. Thank you very much for the interview.
Sure. Always a pleasure.
Always a pleasure.
Cheers.